Hello, in this video we will talk about the determinant equation of line. Suppose you are given three different points and you want to check whether these 3 points are lying on the same line or not. Okay, before explaining this thing, I want to tell you that if you have 2 points, any 2 points, for example, one point is here, the other point is here, you can always draw a straight line which passes through these 2 points. For example, if I draw the straight line which passing these 2 points, I can do that. I have to just manage, I have to rotate it a little bit. I can always draw a straight line which passes through the points. But if I have 3 different points, I cannot always do that. Okay, if you are given any 2 points, you can always do that. For example, the first point is here, the other point is here, you can always join them. If the first point is here, the other point is here, you can still join them by straight line. But if you have 3 different points, the first point is here, the second point is here, the third point can be anywhere. Okay, for example, if the third point is here, you cannot join these 3 points by a straight line. For example, if I draw a straight line passing through these 2 points, that line cannot cover this point. But if I draw any line passing through these 2 points, this line cannot cover this point. If I draw a line passing through these 2 points, this line cannot cover this point. So that means if you are given 3 different points, they may or may not lie on the straight line. They can lie on the straight line. For example, if the one point is here, the other point is here, and the third point is here, then they are lying on the straight line. So it is possible. So how can you check whether the 3 points are lying on the straight line or not? Okay, so for example, you are given a line. We will check whether these points are lying here, this point is lying here, this point is lying here or not. How we will check? First of all, for a given line, we will write its mathematical form. This is the line, but its mathematical form is what? Its mathematical form is ux plus vy plus w equal to 0. So this equation is a line actually. Whenever you will write this equation, this means this equation represents this line. Okay, so if you want to see whether this point is lying on this line or not, what you will do, you will replace, since this is x and this is y, so you will replace this x and y by these 2 points, these 2 values. If this line is gives you the correct answer, that means this point is on this line. Similarly, if you want to check this point, whether this point is lying on this line or not, what you will do, you will replace this x by 7 and this y by this 7, and you will again check whether after putting x and y values, this equation gives you the true solution or not. Similarly, if you want to check this point is lying on this line or this is away from this line, what you will do, you will replace this x by 1 and you will replace this y by 3. Okay, so after replacing this x and y by these values, if you get this equation identity or true, then that means this point is also lying on this line. It is not away from this line. So this is the basic principle. Okay, this principle will be used to check whether 3 points, any 3 points can be drawn, can be checked whether they are on the straight line or not. Okay, so the question is, how can you make this equation of line? For example, if I give you any line which is passing through 2 points, so I told you any line can be determined by any 2 points. For example, if I give you these 2 points, the line will be this one. If I give you these 2 points, the line will be this one. You know, this line and this line are totally opposite, they are not the same. So that means any line can be drawn through the 2 points. Okay, so if I will give you 2 points, that means I am giving you the line. Which line? The line passing through these 2 points. So that means if I giving you 2 points P and Q, that means I am giving you a line, and that line can have mathematical form. I mean, in other words, this line can be represented as this equation. So the question is, if you have this line, how can you write this equation? This is the question which we will answer in the next step. So we will suppose that we have 2 different points and we want to make a straight line through those 2 points. Okay, for example, this point is here and this point is, for example, here. Then how can you draw a line through these 2 points? For example, these are the 2 points. How can you draw a line? Just by joining these 2 things. Okay, so what will I do? I will write the general form of equation of line, then I'll put both of the points in that equation, in those equations of lines, and we can find the general equation of line for these 2 points. Since the general equation of line is this one, so I will call it equation number 1. So I will put now this point and this point in this equation of line. Okay, so for point Q 1, 2, what will I do? I will replace this x by 1. I will replace this y by 2. Okay, so I will write u times 1 and v times 2 plus w equals 0. Okay, so if I solve it, it will be 1 times u, which is u, plus 2v plus w equals 0. I will call it equation number 2. But now I will put this point in the same equation. What will I do? So for this point, I will again write the same equation, this equation, but this time I will replace this x by 5 and this y by minus 4. Okay, so u times 5 plus v times minus 4 plus w equals 0. If I solve it, I will have 5 times u minus 4 times v plus w equals 0. I'll call it equation number 3. That means I have 3 different equations. Okay, so I have put it 2 different points on the general equation of line. What I have 3 different equations, equation number 1, 2, and 3. If I write the 3 equations at one place here, then you can check we have a system of equations. So we had initially 2 points, we put it onto this into this equation of line, and we have 3 different equations. That is the system of linear equations. Here the variables are u, v, and w, which are available in all of the equations. So we have 3 different equations, 3 different variables. We can solve it. So that means our system is ax equals to b. But in this system, our variables are u, v, and w. So that means this x is u, v, w. Okay, so x is u, v, w, and the constants coefficient matrix A is here x, here y, and here 1, because the coefficient of u is x, the coefficient of v is y, the coefficient of w is 1. So x, y, 1 here, and here the coefficient of u is 1, coefficient of v is 2, the coefficient of w is 1. So 1, 2, 1. Similarly, the last row 5 minus 4, 1. Okay, and b here is 0. So we can solve this system. Okay, so in order to solve this system, we have to keep in mind this is not the general system of equation of line. The general system of equation of line is ax is equal to b, but here instead of b we have 0, right? That means I can write here 0 because the matrix b is 0. Okay, so this system is called homogeneous system of linear equations, and the previous system which we have done previously, ax is equal to b, it was non-homogeneous. Okay, non-homogeneous. So for the non-homogeneous we use Cramer's rule and the other things, matrix inversion method and row echelon form, etc. But this is the homogeneous system. It has different scenario. The homogeneous system, so we have two cases. Okay, since the homogeneous system is ax is equal to 0, that means this is one matrix, this is another matrix. The product of two matrices is 0. So what is the possibility? The possibility is we have two cases. Case 1 is either this matrix is 0. Case 1 is x is 0. Okay, and case 2 is that x is not equal to 0. Okay, so these are the two possibilities. So first of all, in the first case we will consider the first possibility. If x is 0, then here I can write any matrix. That means these values can be any. Okay, so I can write any values in A, because when I will multiply any value, any matrix with 0 matrix, I will get 0. So that means A is any matrix. So if A is any matrix, that means in particular we can take a matrix whose determinant is not equal to 0. That means we can pick a matrix A whose determinant is not equal to 0. So if the determinant of A is not equal to 0, then as in the previous examples using the Cramer's rule, we proved that if the determinant of A was not 0, that means we could have a unique solution. Okay, so that means if the determinant is not equal to 0, then we have unique solution. That unique solution is in fact x is equal to 0. So that means for this case we have only 0 solution. There is no other solution. Since there is no other solution, that means the point P of xy does not lie on the line. Okay, so go towards case 2. Case 2 says the matrix x is not equal to 0. That means we have ax is equal to 0. This means if this is not equal to 0, then the determinant of A must be 0. This means the determinant of A must be 0. Because if the determinant of A will not be 0, then their product will not be 0. Since the product of both of the matrices is 0 and x is not 0, therefore the determinant of A is 0. It has to be 0. Otherwise, this thing will not be true. Okay, since the determinant of A is 0, this means in this system, this x can be arbitrary. Okay, this x can be arbitrary non-zero element. So that means the point P of xy lies on the line. So we conclude that the point P of xy lies on the line if and only if the determinant xy1 1 2 1 5 minus 4 1 is equal to 0. Okay, so if this determinant is equal to 0, that means the point is lying on the line. If this determinant is not 0, that means the point is not lying on the line. This is the general criteria. Okay, so we will continue this case because our aim was to find an equation of line. So from here I can find an equation of line. If I expand this determinant using this row, what can I do? So I will write these elements and their cofactors. So for example, I will write first x. I'll write negative 1 to the power 1 plus 1 times x times the determinant obtained by deleting this column and this row, 2 1 minus 4 1 plus again minus 1 to the power 1 plus 2 because of this number. This number is lying on the first row and second column. Therefore 1 plus 2 times y times the determinant obtained by deleting this row and this column, 1 1 5 1. Again minus 1 to the power 1 plus 3 because of this number, and this number is lying in the first row and the third column. Okay, and this number is 1, and then I will write its minor, the submatrix obtained by deleting these two things. I will get this thing, 1 2 5 minus 4, since this whole thing is 0. Okay, so this is equal to x times 2 times 1, because this minus 1 to the power 2 is even number. So x times 2 times 1 is 2 minus the product of these two, minus 4 times 1, minus 4 times 1. Okay, then I will write plus minus 1 to the power 3 is odd number, so I will write minus here, minus y times the product of these two, which is 1, minus the product of these two, which is 3, plus this is plus 1 because minus 1 to the power 4 is even number. I will write 1 times the product of these two, which is negative 4, minus the product of these two, which is 10, equals 0. Now if I solve these things, I will have x times 2 plus 4, okay, minus y times minus 2 because 1 minus 3 is minus 2, and this is 1 times minus 14, so I will write minus 14, which is equal to 6x plus 2y minus 14 equals 0. So this is the equation of line. This is the equation of line passing through the points which were given initially. So in general, if you are given any 2 points, x1 y1 and x2 y2, for example this point is Q, this point is R, and you have an equation of line passing through those 2 points. This is Q and this is R, okay, and if you have any other point P of x and y lies on the line obtained by Q and R, okay, line determined by Q and R. If this point lies on the line, then this point must satisfy the equation. This point must be here somewhere on this line, okay. In other words, mathematically, if this is the equation ux plus vy plus w is equal to 0 is the equation of the line QR, then this point must satisfy this equation. And in this case, the system of equations ux plus vy plus w equals 0, ux1 plus vy1 plus w equals 0, and ux2 vy2 plus w equal to 0 has has non-zero solutions. Because if this system has only zero solution, then the determinant must be not equal to 0. But we need the determinant to be 0, and determinant is only 0 when this system has non-zero solutions. So we will say in this system, u, v and w has non-zero solutions, have non-zero solutions, which means that the determinant of A is equal to 0. What's meant by determinant of A? X, Y, 1, X1, Y1, 1, X2, Y2, 1. This whole thing is equal to 0.